Here's an example of an average speed problem. Jaime was driving home. He drove for 30 minutes on the highway at 60 miles per hour. Then he turned off the highway and drove north for 15 minutes at 30 miles per hour. He then drove east for 15 minutes at 20 miles per hour. What was his average speed? The tricky thing here is interpreting what the question means by average. We know there are many different statistical averages, mean, median, mode, etc. When someone asks for the average speed without any descriptors, they really mean the time-weighted average of the speed. The other tricky thing in this problem is that it has a lot of distractors. It tells you information about direction, and if you are wanting average speed, the direction doesn't matter. So you can neglect all of those. If, on the other hand, they ask for average velocity, you'd need to do some vector addition of the different motions. We'll talk about vectors next week. Okay, so Jaime spent half his time driving at 60 miles per hour. And he spent a quarter of his time driving at 30 miles per hour. And 1/4 driving at 20 miles per hour. Thus, his time-weighted average speed is simply half of 60, 1/4 of 30, and 1/4 of 20 added together. And so his average speed was 42.5 miles per hour. Now, there's a more automated way to do this, which is rather than first having to calculate the fraction of time spent thing, you just weight each speed by the time spent doing it, and then divide by the total time. Note, I put my units in here so I can keep track of things. So this expression has mixed units. There's miles, hours, minutes. But when I do my division, these minutes are all going to cancel. I'm going to get an answer in miles per hour. If you don't keep track of your units in this way, it's very hard to make sure you don't make a mistake here. Anyways, if I plug this into my calculator, I again get 42.5. Note, this is also the same result you'd get if you stretch the path out into one line and calculate the magnitude of the average velocity. The numerator is the total distance traveled, and the denominator is the total time that it took. As a mnemonic, we could write a little formula. That is, we take the numerator where we weight each velocity by the time spent at that velocity, and divide by all the times. Now, some introductory physics courses are structured around such mnemonics and focus on developing a list of formulas and strategies for selecting which formulas to use. Most physicists, and most students for that matter, view such courses as intellectually unsatisfying. My goal is to instead instill the spirit of modeling and interpreting that goes into the material we cover. For example, you should be aware that density is a measure of mass contained in a certain volume. Imagine I make a yard sculpture by brazing 100 cubic centimeters of iron onto 200 cubic centimeters of aluminum. And someone wants to know, what is the average density of the sculpture? Okay. And we could have a formula for this kind of thing, but this is really the same reasoning as we did for velocity. So when they're asking for average, you have to say what average they mean. And in this case, the natural thing is a volume-weighted average, in which case we would have Now, neither of these are difficult problems. Despite involving different quantities, you should recognize that they rely on the same reasoning. So, finally, let me say that although I said a few disparaging remarks about, organizing things by formulae and things, they provide a very powerful and concise way to summarize quantitative relationships. And you're not going to succeed in this course unless you become familiar with the formulas which describe the models that we use to understand nature. But I really do want to emphasize that the intellectual merit is not in memorizing formulae, it's understanding the models that underlie them.